on this semester. This officially is our very first target as a physics target. So this semester we are completely honed in on physics. So what exactly do we study in physics? It is the study of motion and energy. So you've already had the opportunity to test out some ideas that you have about motion. So very simply, we're going to eventually move into like the laws of motion. Why do objects change their motion? What are forces that make objects change what they're doing? Now, very simply, motion is a change in position relative to a frame of reference. I'm not going to highlight that because most of you understand that. I do want you to highlight frame of reference. A frame of reference is a point from which movement is determined. So take a moment and write point from which movement is determined. So here's the deal. Not all motion on Earth is easy and obvious to see. For example, in ancient times, they had some weird ideas about the sun and the moon and the earth. What did they think? Did the sun go around the earth or the earth around the sun in the earliest times? They thought the sun went around us. They thought that the sun went around us. Does the sun go around us?
No.
How does it actually work?
We go around
the sun. Do you notice the motion that we have right now on Earth? For example, the Earth spins on its axis and we get day and night. Do you sense that motion? Do you see that motion? You might see the sun shifting in the sky, but very simply, some motions are not easy and obvious because you don't have a frame of reference. You don't have a beginning and end to see where motion started and where it ended. The speed limit, you guys know what this is? 186,000 miles per second. This is the fastest thing in the universe. What is it, by the way?
Light.
It's the speed of light. Do you have any idea how long it took them to figure out how fast light travels? What they had to have was a beginning and an end. Some guy who came up with measuring the speed of light, he had the light and he bounced it off a whole bunch of mirrors. He was able to figure out how far did the light travel, how much time did it take, and he was able to calculate how fast light actually travels. It was crazy, mind-boggling how fast it really is. So very simply, you guys, a frame of reference is something fixed in place, and it's simply you have to have a beginning and an end. Consider the lab you just did with the car and ramp. You had two photo gates. What started the measuring of the motion? The first photo gate. What stopped the motion? The second photo gate. So very simply, we're going to learn that in order to calculate speed, we have to kind of have a beginning and we have to have an end. Now here's a goofy little scenario. Let's say I look out my window and I see the mail truck is outside by my mailbox. I go away. A couple minutes later I come back and the mail truck is now in front of my neighbor's house. I didn't see him move, but could I figure out how fast he was going? Yes, I could. So my question is, what was my frame of reference? Where did I begin noticing his motion? Somebody be brave. Where did I begin seeing where did I
When you
measure?
saw him at your mailbox.
My mailbox, exactly. My mailbox was my frame of reference. That's where I began to notice where he was. So my mailbox is my frame. He started here, he's now here. Now technically I could calculate his speed if I knew two things about his motion. A, how far he went, B, how long did it take. Now there's two kinds of speed we're going to talk about, and there's two kinds of speed you're going to measure in the lab. Speed is the distance traveled per set amount of time. So notice, it's distance traveled per set amount of time. So speed can be expressed in miles per hour, centimeters per second, miles per minute. So there's many different units, and what unit you express speed in depends on what unit you had distance in and what unit you had time in. Two kinds of speed. Instantaneous speed, which is speed at any given moment. So do you see the word instant and instantaneous speed? If I look at what's in your car that tells you what speed you're going at any given moment. It's a speedometer. I kept calling it an odometer. That's not a speed. So a speedometer basically measures instantaneous speed. At any given second, how fast am I moving? All right? Now that's to be compared with average speed. Average speed is an overall rate of motion, and very simply, it's different. It's total distance divided total time. So if I'm traveling to Des Moines, I might give you my average speed. Sometimes I'm doing 70 miles an hour on the interstate. I might slow down to 50 because I hate construction. I might stop at the gas station. So I would probably do my total distance divided by how much total time, and I'd give my average speed. And again, instantaneous speed would be the speed at any instant. Today you are going to have one photo gate on your ramp, and you're going to measure the instantaneous speed of the car at that one spot. How fast is it going at this spot? How fast is it going at the middle of the ramp? What's its speed at the bottom of the ramp, okay? Now lastly, velocity, put a star by this. This is the weird wonky part. Velocity basically is speed, but it has more information. It's speed in a given direction. So I want you to add velocity is more specific. So it not only tells me a rate of motion, but it tells me a direction too. So very simply, we call this a vector quantity. For those of you kind of in more advanced math classes, a vector quantity includes a number and a direction. So very simply, this will come into play when we talk about acceleration. Acceleration is a change in velocity, which means you can either have a change in speed or a change in direction. Because basically we're going to learn about Newton's laws of motion, and objects don't move in curved paths by themselves, and they don't tend to speed up or slow down unless something acts on them to make them change their motion. Now here's an example of velocity. 65 miles per hour north. This would be velocity, and the reason it's velocity is because I have a distance over a time and I have a direction. So I want you to write includes direction. Now please write everything on my sheet on your sheet. Don't skip any one part. So 65 miles per hour north would be considered velocity. If I just said 65 miles an hour, then technically it's just speed. You see the difference? So come back up here. 65 miles over hour, this is just speed. So it's just a rate of motion, a distance over a time. If I put a direction on it, technically I now have velocity. All right, so that's just one little thing we're going to have to adjust to, and it's going to become important later when we talk about acceleration. Now lastly, we're going to use a triangle, and the triangle is going to allow us to solve for any one part of the equation. So put a V on the bottom here, put a D on the top, and put a T right here. Now, here's the deal. Some of you are in advanced math classes, some of you are in algebra, and some of you are in algebra half. So this triangle is going to help every single person to keep track of units and be able to know that you've done a problem right. In physics, keeping track of units is like a key part of you being successful. So basically, V stands for speed, you guys. Speed